Hi everyone, in this video I'm going to teach you the chain rule and show you how to solve problems with it. If you already understand what it is and just want to see the examples, please look for the timestamp in the comments or description down below. So let's get into it. The chain rule basically lets you find the derivative of composite functions, which are functions where you have a function inside of another outer function. Let's use this chart down here as an example for what type of functions you'd use the chain rule for and what type of functions you wouldn't use it for. So as we can see here, for the left column, we can just use the rules we already know to find the derivative, like the power rule and trig differentiation, because there is no function inside of another function. But notice that for the right column, there is an inner function and an outer function. So these outer functions could be something like a square root or something raised to the fifth, or a function like x squared inside a trig function. These are composite functions. So to take the derivative of a composite function, we have to use the chain rule. So because they are composite functions, we want to simplify the inside of them by letting u be equal to the inside function. We want u to be equal to the inside function. So we can say that y is equal to f of u. Basically any function with u as the input, like y equals u to the seventh. And we can also say that u equals g of x, so basically any function with x as the input, like u equals x squared, what u is actually equal to. So now we can sub in what u equals into f, and we can just write y equals f of g of x. Thus, dy dx, the derivative of y with respect to x is equal to dy du, the derivative of y with respect to u, times du dx, the derivative of u with respect to x. This makes sense because we can cancel the du's and see we're just left with dy dx right up here. So that's useful to see. So here's a quick example to illustrate what this means. So if you have a function like y equals 8x minus 2 to the 10th power, u is the inner function, so we can say u equals 8x minus 2, because 8x minus 2 is the inner function. So now we can just write this as equivalently y equals u to the power of 10 by substituting that for u. So this is y equals f of u. So now all we have to do to find the derivative dy dx is to do just the derivative of y with respect to u. So 10u to the 9th by the power rule, multiplied by du dx, the derivative of u with respect to x, which is just 8 by the power rule. And this is going to be our answer. This is what the derivative equals. So that's all we have to do. You could combine these if you wanted, but there's no need. Okay. So you can also write the chain rule another equivalent way, which you should be familiar with. So if we have a composite function y equals f of g of x, where f is the outer function, like something to the power of 8, and the inner function is g of x, which can be something like 2x plus 3, to take the derivative with respect to x, so d dx of f of g of x, you just have to take the derivative of the outside, f prime, keep the inside the same, so g of x, and multiply that by the derivative of the inside, so g prime of x. That's what the derivative is equal to. A quicker way of writing the chain rule, which will be useful, is just the derivative with respect to x of u to the n is just equal to n times u to the n minus 1 multiplied by u prime, the derivative of u. So now that I taught you the chain rule and what it is, let's just get right into the examples. So for our first example, let's try to find the derivative of y equals 2x minus 8 to the power of 87. So dy dx is just going to be equal to, so the composite function, the inner function, is going to be 2x minus 8, so that's going to be our u. So we can just bring down the 87 like we would in the power rule, keep the inside the same, subtract 1 from the exponent, so it's going to be now to the power of 86, and then multiply by the derivative of the inside, which is going to be 2. And we could, again, combine these, but there's no need really. Okay, for our next example, let's find f prime of x if f of x equals 5 times 2 minus 2x minus x cubed all to the 4th. So this 5, we can just basically take that out of the derivative, like just add it in later. Like if we were taking the derivative of 5x to the 4th, we would really do 5x 5 times the derivative of x to the 4th. So it's 5 times 4x cubed, or 20x cubed. So basically, for this, because this is the inside, f prime of x would just become 5 times the derivative of the outside, 5 times 4, keep the inside the same, okay, and now we can multiply by the derivative of the inside, so it's going to be negative 2 minus 3x squared, and this is going to be our answer. Okay, for our next example, let's find the derivative if f of x equals the square root of 8 minus 2x squared. Okay, so we can rewrite this as 8 minus 2x squared to the power of a half, like we did when we were trying to find the derivative of radical x. It's the same process. So now taking the derivative of the outside, we can just use power rule. So it'd be a half times 8 minus 2x squared, and then a half minus 1 is going to be negative a half, and then multiply this by the derivative of the inside, which is going to be negative 4x. So let's simplify this a bit more. So this is going to be noticing that the 8 minus 2x squared to the power of negative a half is in the numerator with the 1. If we bring it down to the denominator, it'll all this will be to the power of positive a half. So let's do that. So it's going to be 1 over 2 parentheses 8 minus 2x squared to the power of a half and times negative 4x. Now we can just bring the negative 4x up top. So it's going to be negative 4x over 2. And then a half means a radical, so we can just do radical 8 minus 2x squared. And that's going to be our answer. Whoa, wait, sorry. We can simplify this a bit further actually by canceling the 4 and 2. So it's going to be negative 2x over the square root of 8 minus 2x squared. And that's the final simplified answer. Okay, so now let's try finding the derivative of y equals 1 over x squared minus 9 to the power of 4. So we could do this using the quotient rule, but we could actually do this using the chain rule. So we could rewrite y as 1 times x squared minus 9 to the power of negative 4. And this is equivalent because if you bring a positive exponent from the denominator up to the numerator, it has to be negative. So now we can just use the chain rule for this. We can ignore the 1 too. Let's get rid of that. Okay. So we can use the chain rule to find dy dx now. So now this is the inside function. That's going to be our u. So it's the derivative of the outside using power rule, negative 4 times, keep the inside the same, times x squared minus 9 to the power of negative 4 minus 1, which is going to be negative 5, and then multiply by the derivative of the inside, which is just 2x. And we can simplify this further because we don't like having negative exponents. So it's going to be negative 4 over x squared minus 9 to the power of 5, like we did with the x to the power of, like we did with this one up here. We brought the negative a half back down to make it positive. So it's the same thing. And then this is multiplied by 2x. The key is to also realize the negative 4 does not come down with this. Don't bring it down because it's not attached to it. Okay, so now we can just multiply the negative 4 by 2x. So we're going to have negative 8x over x squared minus 9 to the power of 5. And that's our final answer. Okay. So for our next example, let's find the derivative of h of x. Let's bring it down a bit. H of x equals x cubed times 4x minus 2 to the power of 5. So we have to realize here is that we have to use product rule. So this will be f and this will be g. So the product rule states that h prime in this case will be equal to f prime g, the derivative of f, times g, plus f g prime. Some books or some teachers or professors have this in different orders, but it's all the same thing. It's just what order you take the derivatives in. So let's do that with this. So h prime of x is going to be equal to f prime, which is just 3x squared. G stays the same, so it's times 4x minus 2 to the power 5. Now f is the same, add. So f is going to be the same, so it's x cubed. And then g prime we have to use the chain rule for, so we're combining the product rule and the chain rule. So 4x minus 2 is the inner function, so we differentiate the outside, and we're going to have 5 times 4x minus 2 to the power of 4 times the derivative of the inside, which is just 4. And that's going to be our answer. You could simplify this a bit, but that's not really necessary. This is the derivative. Let's try another example. So let's find the derivative of g of x equals 3x squared minus 2 all over 2x plus 3 to the third power. So what we have to realize here is that we're going to have to use quotient rule. So first let's use, this is going to be our u, our inner function. So we can use chain rule and take the derivative of the outer function. So it's going to be, so g prime of x equals 3 times 3x squared minus 2 over 2x plus 3 raised to the second power. And now we're going to have to use the quotient rule. A way I like to remember the quotient rule is by the mnemonic low d high minus high d low over low squared, where high stands for the numerator and low stands for the denominator, and dE stands for derivative. So, wait, no, let's keep this up here. Let's keep this up here so we can refer to it. So the derivative of this, our low function, is going to be 2x plus 3. And the derivative of the high is going to be 6x. And then minus our numerator, the high. That's 3x squared minus 2. And then multiplied by the derivative of the low, the denominator, which is just going to be 2. And this is all over low squared, which is 2x plus 3 squared. And so this is going to be our long answer for this problem. You could simplify it, of course, a bit more, but again, there's no need really. Now let's move on to some examples with trig functions. So let's find the derivative of y equals cosine of 4x. So what we have to realize here is that this 4x is going to be our u, because it's the inner function, and the outer function is just our trigonometric function, in this case cosine. So we just take the derivative of the outside, which is going to be negative sine keep the inside the same, negative sign of 4x, multiply by the derivative of the inside. That's going to be multiplied by 4, and that's going to be our answer. Let's try another example. How would you find the derivative of y equals tangent of x squared? So again, the x squared is going to be our inner function, and then the tangent's our outer function. So y prime is just going to be the derivative of tangent, which is secant squared. Keep the inside the same, secant squared of x squared, multiplied by the derivative of the inside, which is just 2x. That's the answer. Let's do another example. Let's find f prime of x if f of x equals 4 secant squared of x. So the first thing we want to do here is we don't like the squared right there. It's hard to visualize what's going on. So let's bring it out. So it's going to be 4 times secant of x, and it's secant x squared. Okay. So it's sort of like u is 4u squared. It's like that, where u is secant x. So that means f prime of x is just going to be 4 times 2 using the power rule, and then keep the inside the same. So secant x, and then it's to the power of 1, but that's redundant. We don't need to write that. And then we have to multiply by the derivative of the inside, which is secant x. So the derivative of secant x is secant x tangent x. So now we're going to multiply by secant x tangent x. And this is going to be the answer. Okay. We'll do some more complicated trig ones later. But first, let's do some examples with ln of x and e to the x real quick. So let's find the derivative of f of x equals ln of x squared. So for this, we have to remember that the derivative of ln is 1 over x. So the derivative of ln of u, the derivative of ln of u, where u is a like an inner function, that's going to be 1 over u times u prime. So it's basically just the chain rule. So in this example, f prime of x is just going to be 1 over u, the inner function. So 1 over x squared multiplied by 2x. Then we can cancel the x's, and it's going to be 2 over x. That's going to be our final answer. Okay, sorry. Now let's find the derivative of g of x equals ln x to the power of 4. So ln is going to be our inner function here, so it's going to be u to the 4th. So g prime of x is going to be the derivative of the outside. So 4, keep the inside the same, ln x cubed times the derivative of the inside. So it's the derivative of ln x, which is just 1 over x. And then that's our final answer. Now let's find the derivative of h of x equals e to the 4x 4x plus 5. So what we have to remember here is the derivative of e to the x is just e to the x. And applying that to the chain rule, the derivative of e to the u, where u is an inner function, is going to be e to the u times u prime, the derivative of u. So let's get rid of this real quick. So for this example, h prime of x is going to be equal to e to the u, where u is 4x plus 5, multiplied by u prime. So it's the derivative of 4x plus 5, which is just 4. That's the answer. Let's do another example with e to the x. Alright, so now let's do the derivative of y equals 4 times e to the x to the power of 9. Now we could actually simplify this by writing it like 4 times e to the 9x, because we can just bring the exponent into it. But let's differentiate it how it was originally written, just so we can see how it works. So this is really 4u to the 9, where u is e of x. So it's going to be 9 times 4. So it's just going to be 36, bringing down the 9 due to the power rule. Keep the inside the same. Then lower the exponent by 1. And then multiply by the derivative of the inside, which is just e to the x. And that's our answer. We could simplify this because this is another e to the x, but this isn't algebra. This is calculus, so we don't need to do that. So now let's learn to apply the chain rule to even more complicated functions. So the chain rule applies for something more complicated, like if g has a function h inside of it as well, like y equals f of g of h of x. So this just follows the same pattern. Y prime would be f prime of g of h of x, where you keep the where you differentiate the outside and keep the inside, which is this, the same, and then you multiply by the derivative of the inner outside function, which is g, while keeping the innermost h of x the same, and then multiply by the derivative of the innermost function, h prime of x. And the same pattern applies if h had another function inside of it, and that function had another function inside of it, and so on. So let's do some examples with this more complicated version. That's not really more complicated, just a bit more steps. So let's find the derivative of f of x with respect to x when f of x equals 3 plus 2x to the power of 4 minus 1 cubed to the power of 8. So the derivative of x with respect to x using the chain rule. This is going to be our inside function. So we can differentiate the outside. So it's going to be 8, keep the inside the same. So 3 plus 2x to the 4 minus 1 cubed all to the 7th. So now we have to multiply by the derivative of the second outermost function. So let's do that. So the derivative of 3 is just 0, so we can ignore that. So it's really the derivative of this. So the derivative outside is just going to be 3 times, keep the inside the same, 2x to the 4 minus 1. Then it's squared. And now we can multiply by the derivative of the innermost. So it's just going to be 8x cubed. And so this will be our answer. So for our next example, let's find the derivative of f of x with respect to x when f of x equals sine of cosine of pi x plus pi to the power of e. Okay, so the derivative of x with respect to x. Let's find that. So we have to realize this is going to be our u because it's the inner. So we have to just differentiate this and keep this the same. So it's going to be cosine because that's the derivative of sine, and keep all the inside the same. Pi x plus pi to the e. Now let's multiply by, or let's take the derivative of the inside. So this is the inside now, multiply by the derivative of that. So the derivative of cosine is negative sine. But because this requires 3 applications of the chain rule, we have another inner function. So we're going to keep this the same. So it's negative sine of pi x plus pi to the power of e. And now we're going to take the derivative of this, the inside, of negative sine. So the derivative of pi x is just pi, and don't get tricked here. The derivative of pi to the e, because it's a constant, is just 0. So it's just pi. And so this is going to be our long answer. Let's move on to the next example. So let's try to find the derivative if f of x equals sine squared of sine of x. So like we did in the secant example earlier, let's move this outside so it's easier to see what we're working with. So it's going to be sine of sine, or sorry, this is not what f prime of x equals. This is a simplified version of f of x. So it's sine of sine of sine of x, but it's squared. Okay, because this squared will apply to right there, where it was over there, where it was earlier. Okay, so f prime of x, that's just going to be, this is going to be our u, so we can just use the power rule on the outside. So it's 2 times sine of sine of sine of x, and to the power of 1. We don't need to write that. And now let's keep on differentiating, working our way into the innermost. So now we're going to take the derivative of this. So it's going to be, this is our inside, and this is our outer function. So the derivative of sine is cosine. So it's multiplied by cosine. of, keep the inside, this is our u, keep that the same. Cosine of sine of x. And now this is going to be our inside. So we just multiply by cosine again, because the derivative of sine is cosine. And this is our inner right there. So it's cosine of sine of x, and then multiply by the derivative of sine of x, which is cosine of x. And that's going to be our answer. So it gets even longer. So this is going to be our answer. Let's move on to another example. So let's find the derivative when f of x equals 8 sine to the power of 4 of 9x squared minus 2x. So again, let's rewrite it. So f of x equals 8 sine of 9. Let's put a parenthesis there, sorry. Of 9x squared minus 2x to the power of 4. So this is going to be our inner function. So it's like 8u to the 4th. So using the general power rule, it's going to be 32, because 8 times 4 is 32. 32 times sine of 9x squared minus 2x. And then this is to the power of 3. Now we take the derivative of this portion. So this is our innermost, and this is the outer. So that's the derivative of sine, which is just cosine. So it's multiplied by cosine of, keep the inside the same, 9x squared minus 2x. And now multiply by the derivative of the inside. So multiply by 18x minus 2. And that's our answer. So we're going to do a couple more examples. So let's find the derivative when f of x equals e to the 4x minus cosine x. So because the pattern is the derivative of e to the u, it's just, as I said earlier, e to the u times u prime. The u is e to the 4x, or the u is 4x minus cosine x. So we're going to keep that the same originally, or for now, and then multiply by the derivative of it. So the derivative of 4x is 4, and the derivative of negative cosine x is positive sine x, because the negatives cancel. So that's going to be our answer. Now let's do our final example. So f of x equals 5x to the power of 45 to the power of 40. That's awful, sorry. 5x to the power of 45 multiplied by ln of 4 x to the 7th plus 2. So we have to realize here that these are two functions being multiplied together. So we're going to have to use the product rule. So this is going to be f, and this is going to be g. So remember the power rule states, as I said earlier, f prime g plus fg prime is the derivative of it. So it's going to be f prime of x equals the derivative of 5x to the power of 45 is 5 times 45. So 45 times 5. I should know that off the top of my head, but I sadly don't. So it's going to be 5 to 225. So it's 225 x to the 44. And then g is the same. So 4x to the 7th plus 2. And then we're going to add, so it's going to be f, that's the same, so 5x to the 45, and multiply by the derivative of g, so it's going to be 1 over 4x to the 7th plus 2 times the derivative of this, which is just 28x to the 6th. And that's going to be our answer. Alright. If you like this video, make sure to subscribe to my YouTube channel. Let me know in the comments down below if this video helped you or did not help you understand the chain rule. Thanks for watching.